Hello Stonehill students. Today we will talk about surface area and volume of solids. We will learn about two types of solids. Take a look at the first one. There is no curved surfaces whatsoever. We call them a polyhedron, each one of them. A polyhedron is a solid that is bounded by polygons called faces, and the edge of the polyhedron is a line segment formed by the intersection of two faces. Those are the edges, and the vertex, take a look here for example, is a point where three or more edges meet. So let's take a look at the non-polyhedral surfaces. As you can see, at least one of the surface would be curved. That's why it's not a polyhedron. Okay, so let's take a look at the first one. Let's see the example 1a. Is this a polyhedron? Yeah, there is no curved surfaces. This is a polyhedron. Let's calculate faces, edges, and vertices. Faces, 1 on the bottom and 3 on the side. That will give you 4 faces. Okay, edges, carefully. 3 on the bottom and 3 coming to the vertex on the top. So that would give you 6 edges. And now let's recognize the vertices in here. 1 on the top, 1 here, 1 here, 1 here. So that would give me 4 vertices. We can check our calculations. Will it work or not using the Euler theorem? Let's take a look. It states that the amount of faces plus the amount of vertices should give you the amount of edges plus 2. Using this, let's come back and check it out. The amount of faces, 4, plus 4 vertices. Will it give me 6 plus 2? Obviously will. So yes, our calculations are correct. Okay, guys, now you will need to pause the video and calculate, do the same calculations for this example and this. Tell me, is it polyhedron or not? How many faces, edges, and vertices? Check it with the Euler theorem and also this problem. So stop the video and let's do that so you can check it with my answer later. Okay, that's what I got for the problem number 1a. And 1c is definitely not a polyhedron, so we're not calculating those. And that is my answer for example number 2. Okay, now let's talk about the prisms and cylinders. Those have two bases parallel to each other. Take a look, one on the bottom and one on the top in each of these examples. And then they all connected with rectangles. So, or parallelograms if you have oblique. But if there are right prisms or cylinders, meaning they raising up vertically, you will have rectangles as a lateral faces. So here's the word. Bases are on the parallel, I'm sorry, on the top and bottom, and lateral faces are the one that connecting the bases. So the height is the distance, perpendicular distance between the bases. So surface area of the right prism. Let's fill in the formula. The surface area is going to be the 2 capital B, this is important, plus capital P and lowercase h. Let's talk about that, what's going on. Capital B stands for the area of the base. It can be the area of triangle, square, or rectangle, depending what kind of shape is your base. In that case, this is the hexagon. In that case it looks like a square. In that case the base is a triangle. In that case is a circle. So it's going to be find the area of the base multiplied by 2. Then comes the perimeter of the base. So you will need to add all the sides here or here or here to figure out the perimeter and multiply it by the height of your shape. The formula of the surface area of the cylinder is almost the same as the previous one. Two bases plus, and here's supposed to be a perimeter, but in our case we do not have a polygon as a base, we have a circle. So instead of calling it a perimeter, we will call it a circumference, but we still need to multiply by the distance between those two bases. I will walk you through the first example in here because this is the most confusing. A lot of people, first of all, do not recognize that this is the triangular prism. They used to see the bases on the top and on the bottom. In that case, actually, the two surfaces that are parallel to each other are those. These are your bases. So base has a shape of a triangle, and then it's connected with another base with rectangles. So if my base is a triangle, I need to figure out the area of the base first. And the area of the base is going to be the area of the triangle. So it's going to be 1/2. The lowercase b, showing me that this is just the base of this triangle, is a line. That's why we're using the lower case, times the h. Let's plug in the numbers. It's 1/2 times 6 times, what is the height? And please remember, I'm looking for the height of the triangle. So let me draw it right here. That's the height that I'm talking about, and I need to multiply, but it was not given to me. So let's see what I have. I have half of the base. Well, this is another half. The bottom half of the bottom line is 3. This is 6. I do have the right angle, and here's my height. Using Pythagorean theorem, it's going to be the height squared is 36 minus 9, which will give me 27. So the height, if you will calculate on calculator, is going to be about 5.2. So that is the number that I will plug in here. And that would give me the area of the base of the prism is going to give me 15.6. And now let's use the formula. The surface area is going to be two bases. So it's 2 times 15.6 area of the base, not just the base, 2 area of the bases, plus perimeter of the base. It's going to be 6 plus 6 plus 6, which is 18, times the height. And this is getting very confusing because we keep using the same lowercase h. However, please remember, in the formula, the height means the distance between two bases. So you're supposed to multiply it by 8 in here. Okay, if you will calculate everything carefully, it is 175.2 inches squared, because surface area is two-dimensional, so inches squared. Let's consider another example now with the right cylinder. In order to calculate the surface area, you will need to remember that the area of the circle is calculated with the formula pi r squared, and the circumference is going to be 2 pi r. We will need those. So let's see. This surface area, let's start plugging in everything what we have. It's supposed to be 2 area of the bases. So 2 and then pi r squared, pi, my radius is given, it's 4 squared, plus then circumference times the distance between the bases. So it's going to be 2 pi, and then comes radius again 4, and the distance between the bases is 5. And if you will multiply, this is going to be 16 times 2, 32 pi, plus 40 pi. I'm using pi as a variable till the very end. So it's going to be 72 pi. After multiplying, I will figure out it's 226.19 m squared. Okay, guys, use example 1 and 3 to do number 2 and 4 by yourself. Pause it and then check the answers. Okay, here are my answers: 238 square feet and 8.5 millimeters. Just millimeters, it's just a height. As opposed to prisms and cylinders, pyramids and cones do not have two bases. They have only one. And from that base, all the lateral faces coming up to just one vertex. That is why the lateral faces are not rectangles but triangles. You can see it on example of the rectangular pyramid here or the square pyramid here, and the cone kind of doing the same. It's just because the base is the circle, we do not have the triangles in there. We will calculate it a little bit differently. So, surface area of a regular pyramid. Think about that. Surface area, we need to add all the faces again. But there's only one base, so you will calculate the area of the base and you will start from that. Plus, and my faces are not rectangles now, it's triangles. That's why there should be 1/2 times perimeter times the lateral height of the triangle. So it's not the distance between the base and the, well, vertex in that case, but the height of the lateral triangle. So starting somewhere from here and going to the vertex along that face. That's what L stand for. We call it slant height. Surface area of the right cone starts the same. There is only one base, here it is, and then you multiplying 1/2 times circumference times the slant height. So in that case, let's change it to the pi's and the r's. So it's going to be, surface area is going to be pi r squared, that's the area of the base, plus 2 pi r is the circumference divided by 2 will give me just pi r times L. Out of all examples that follows, let's do number 2 because it seems to be a bit complicated because the hexagon is the base. So let's review how to calculate the base of the area of the hexagon. In that case, it's going to be 1/2 times apothem times the perimeter. So let's see, it's going to be 1/2 times 4 square root of 3, it's this part, so times 4 square root of 3 times, and my perimeter is going to be 8 times 6, 48, which will give me the area of the base 96 square root of 3. Wow, a lot. Okay, so the surface area, again, it's the pyramid. So just one base, 96 square root of 3, plus, and here it comes 1/2 times perimeter again, 48, times the slant height, which is right here. As you can see, it's given to you as 18. So let's multiply and add together. It's going to be 96 square root of 3 plus 432. And we cannot simplify anymore. So let's just calculate. It's about 598.28 inches squared. Guys, try to do number 1 and 3, and then let's compare the answers. Well, in the first one, they did not ask you to find the surface area. They just ask you to find the area of each lateral face. And for that, you need to calculate the slant height L, this one. And from the given data, you must use the right triangle right in here and apply Pythagorean theorem to figure out that the lateral slant height, I'm sorry, is 106.93, and then plugging in into the area of a triangle, calculate, this is the answer. And the surface area of the right cone was calculated right in here. Okay, let's talk about the volume of prisms and cylinders. Strictly talking, it is always the area of the base times the height, no matter what the base is. So look at this. If the base is the circle, then still the area of the base, pi r squared, times the height, the distance between the bases. Example number 1, find the volume of that solid. One more time, is it a prism or is it a pyramid? Because I do not see top matching bottom. It's because this prism is lying on its side. There are two bases. One is this one, and second one is this one. Do you see they parallel to each other and connected with the rectangular lateral faces? So this is the triangular prism. Now we will need to calculate the volume. So again, the volume is going to be the area of the base times the height. In my case, the area of the base is a triangle, so it's 1/2 the base of the triangle, which is 3, times the height of the triangle, which is 1, and the whole thing should be timed by the height of the prism, which is 2. If you will calculate carefully, it is 3 feet cubed. And that's how you do every problem in here. Now let's take a look. Number 3 is a little bit different. Composite solid. In that case, you either will be subtracting the volumes like in example 3a because there is a hole in my original triangle, or you will be adding the volumes like in 3b because I had the cube and then another shape is added on the top of that. Let's do 3b together. You can recognize there is a cube and the half of the cylinder is on the top. So the volume of the cube is going to give you side times side times side, which is 4 cubed equals 64. Then look at this cylinder. First of all, it's just 1/2 of the cylinder. This is really important, please. So let's see. The volume of the cylinder should be pi r squared times h. So I'm writing this 1/2 because I'm looking only for the half, and then pi r, in my case, is going to be 2 squared, and times h means height of the cylinder, which is 4. So let's see. 1/2 times 16 pi, which will give me about 8 pi, which is 25.13. And then finally, so the volume of the whole thing is going to be the volume of the cube, this one. Let me use another color. Cube plus the volume of the cylinder, this number. And if you will put them together, it should give you 89.13 inches cubed. Guys, do 3A. There is nothing difficult. You have the big cylinder, calculate its volume, then calculate the volume of the small cylinder, and just subtract. Let's pause and then check. Okay, here I solved it 3A. My answer is 1004 millimeters cubed. Well, volumes of pyramids and cones look almost the same, except you need to multiply it by 1/3 and then times area of the base times the height of the pyramid or cone. Example 1, I would say, is the most difficult because of the shape of the base. Again, the volume is pretty straightforward. It's just 1/3 times the area of the base times the height. However, to find this would be a challenge because that base is a hexagon, and if you remember, it's going to be 1/2 times apothem times perimeter. Well, perimeter is really easy to find. 6 times 4 is 24, but apothem, we will need to see a triangle in here. It's like this. Let me draw it a little bit bigger. The triangle that coming to the right in the middle of the center of the hexagon. So the bottom is 4. And let's build the right triangle in here. So I will have, this is 60 degrees because it's a hexagon. And this is 2. So think about that. The tangent of 60 degrees is going to give me, I'm looking for that. That is my apothem. So it's tangent of 60 is the opposite, which is x, divided to the adjacent, which is 2. So from here, x is going to be Tangent of 60 degrees times 2, that will give you about 3.46. Now I will be able to calculate the base. So the base is going to be 1/2 times apothem, which is 3.46, times the perimeter, 6 times 4. Remember, it was 24. Let me erase this. 24. And it's going to give me 41.57. Now we can plug it in into this formula, and it's going to be 1/3 times 41.57 times the height of the pyramid, which is 10. Guys, let's calculate. It's going to be 138.56 inches cubed. I will put it in the box. Please try to do number 2, 3. I will solve them and I will put them on board, and you might check your answers later. Here you can check your solutions and the answers. 3B was a little bit problematic because again we're using the trigonometry to find the height of the cone, but it's still doable. Okay, lesson 12.6 introduce you to surface area and volume of the spheres, and actually it's just two formulas, straightforward. Plug in what's given and calculate the value that you need to find. Guys, I even will not explain it to you. I'm just allowing you to do problems 1, 2, 3, 4 and then check your answers. So let's pause it right now. Did you calculate now? 1 through 4? Let's see the answers. Okay, here are the answers, and in example 3, don't forget we were calculating the volume of composite solids, so you either need to subtract as in 3A or add the volumes as in 3B. This is the volume. And this is the surface area.